Are you preparing for an Azure Databricks interview? Or are you curious about this powerful data analytics platform? Well, you're in the right place. We're about to embark on a journey through commonly asked Azure Databricks interview questions and answers. Whether you're brushing up for an interview or just keen on expanding your knowledge in data analytics, this guide is designed for you. So sit back, relax, and let's dive into some frequently asked Azure Databricks interview questions. Firstly, what is Azure Databricks? Azure Databricks is a powerful analytics platform built around Apache Spark, an open-source distributed computing system. But it's not just any Spark platform. It's been optimized specifically for the Microsoft Azure Cloud Services platform to provide one-click setup, streamlined workflows, and an interactive workspace that enables collaboration between data scientists, data engineers, and business analysts. Now, how does Azure Databricks stand apart from Apache Spark? While it is built on Apache Spark, Azure Databricks is a cloud-based service that integrates deeply with Azure to provide additional features. It comes with collaborative notebooks that allow for team-based data science and a workspace for managing all your resources, which is a significant step up from the standalone Spark. Let's delve into the key components of Azure Databricks. It comprises the Databricks workspace, Databricks runtime, clusters, notebooks, jobs, libraries, and DBFS or Databricks file system. The Databricks workspace is your collaborative environment for working with all your Databricks assets. The Databricks runtime is the heart of Azure Databricks, providing the runtime environment where your jobs are executed. Clusters are the compute resources that process your data, while notebooks are interactive environments that contain live code and visualizations. Jobs are a way to schedule and automate the execution of notebooks or jar files. Libraries are packages of code that can be imported into Databricks, and DBFS is the distributed file system used for data storage. Understanding these basic concepts is crucial in any Azure Databricks interview. Next, let's talk about Databricks Delta and performance optimization. Databricks Delta is a powerful storage layer that adds a new dimension to Apache Spark and big data workloads. It introduces ACID transactions to Apache Spark, which are a set of properties that ensure data validity even in the event of errors or system failures. This means your data is always reliable, which is a critical factor in any data-driven operation. But Databricks Delta doesn't stop there. It offers features like schema enforcement and data indexing, which help maintain the structure and accessibility of your data. Efficient data management is another key aspect of Databricks Delta. This means you'll have fewer worries about data integrity and can focus more on analysis and insights. Now, let's shift gears to performance optimization. Spark jobs in Azure Databricks can be optimized in several ways. Tuning configurations is one approach. This involves optimizing the settings of Spark to match your specific workload requirements. Another way is through the selection of appropriate cluster sizes. The right cluster size can significantly influence the speed of your data processing. Large clusters can process more data quickly, but they also consume more resources, so it's all about finding the right balance. Optimizing transformations is another technique. This means strategically ordering your transformations to minimize shuffling, which is the costly process of redistributing data across partitions. Caching and persisting intermediate data can also enhance performance. By storing intermediate data in memory or on disk, you can avoid repeating complex calculations, saving both time and resources. Finally, remember that performance optimization isn't a one-time thing. It's a continuous process of monitoring, adjusting, and improving. So always keep an eye on how your Spark jobs are performing and make adjustments as necessary. Now you know how to handle questions about performance optimization and Databricks Delta. Moving on, let's discuss clusters, notebooks, and security in Azure Databricks. Clusters are the beating heart of Azure Databricks, representing a set of computational resources primed to process data. This isn't just any old set of resources, though. Oh no. These clusters are dynamically scalable, meaning they can adjust in size based on the workload, offering you optimal efficiency. And the best part? Management of these clusters is handled by the Databricks platform itself, so you can focus on what truly matters, the data. Now let's turn our attention to notebooks. If clusters are the heart of Azure Databricks, then notebooks are the brain. These are interactive documents that house live code, equations, visualizations, and narrative text. But they're not just repositories for information, they're dynamic, collaborative spaces for data exploration, analysis, and visualization. Imagine a playground for data scientists, where ideas can be tested, tweaked, and refined in real time. That's what notebooks offer. But what about security, you ask? Fear not. Databricks takes security very seriously. It employs role-based access control, or RBAC for short, integrated with Azure Active Directory. This ensures both user authentication and authorization are well taken care of. And it doesn't stop there. Databricks also supports encryption both in transit and at rest. So, whether your data is on the move or taking a well-deserved nap, it's always protected. In sum, clusters provide the computational power, notebooks offer a dynamic workspace for collaboration and exploration, and robust security measures ensure your data is always safe and sound. These three components form a powerful triad that makes Azure Databricks such a compelling choice for big data and data science operations. With this knowledge, you can confidently answer questions about these topics. Now, let's discuss DBFS, Databricks Jobs, and Data Import. DBFS, or Databricks File System, is a distributed file system housed within the Azure Databricks platform. It's essentially a layer over Azure Blob Storage that allows you to interact with your data as if it were on a local file system. This makes it incredibly easy to manage and access data, even in a distributed computing environment. The DBFS is a great tool for storing large amounts of data, performing ETL operations, and sharing data across clusters. Next, we have Databricks Jobs. These are essentially scheduled tasks that automate the execution of notebooks or Java archive files. Suppose you have a notebook that you need to run every day at a particular time, or maybe you have a data transformation job that needs to run whenever new data lands in a certain location. You can set up a Databricks job to handle these tasks automatically, freeing up your time to focus on other important work. These jobs can be set to run on a schedule, or they can be triggered by specific events. Finally, let's talk about importing data into Azure Databricks. The platform supports data import from a variety of sources, including Azure Storage, Azure Data Lake Storage, and Azure SQL Data Warehouse, among others. The process of importing data involves creating a data connection, selecting the data you want to import, and then using Spark data frames or libraries like PySpark to manipulate and analyze your data. Remember, the goal is to bring your data into an environment where it can be easily accessed and processed by your Spark applications. So, if you're asked about DBFS, you can talk about it as a distributed file system that makes data management easier. If you're asked about Databricks jobs, you can discuss how they help automate and schedule tasks. And if you're asked about data import, you can explain the process of connecting to a data source, selecting the data, and bringing it into Azure Databricks. This information will help you tackle any questions related to these areas. Finally, let's talk about the Databricks REST API. This tool is a key component of Azure Databricks, an integral part of the broader Azure ecosystem, and it plays a pivotal role in the world of data science and big data analytics. The Databricks REST API, or Representational State Transfer Application Programming Interface, allows users to interact with Databricks services programmatically. This means you can automate processes, schedule jobs, and integrate Databricks with other systems, all through code. It's this flexibility and automation capability that makes the Databricks REST API such an important tool in the data science toolkit. For instance, you could use the Databricks REST API to schedule a recurring job that runs a specific notebook every day at midnight. This could be useful for tasks like daily data extraction or analysis. You could also use it to programmatically create or manage clusters, making it easier to handle large-scale data processing tasks. Another benefit of the Databricks REST API is its integration capability. Through the API, you can integrate Databricks with other systems and tools, such as data storage solutions, data visualization tools, or even machine learning platforms. This makes it easier to build comprehensive data pipelines and workflows. In essence, the Databricks REST API is all about making your life easier as a data scientist or data engineer. It enables you to automate tasks, integrate services, and manage resources, all through a programmable interface. It's a powerful tool that can greatly enhance your productivity and efficiency. With the knowledge shared in this video, you're now better prepared for your Azure Databricks interview. Remember, understanding these concepts is not only beneficial for interviews, but also for your journey in data analytics. Good luck.